let's consider the car. Assuming this box is my car, it has a normal force that is pointing upward. It has a weight which is pointing downward, and because it's moving on a friction surface, it has a kinetic friction pointing to the left. There's no movement, there's no other forces acting on the car. So if we use Newton's second law and say the sum of the forces equals the mass times the acceleration in the x direction, we get that the negative of the friction kinetic force equals the mass times the acceleration. And if we use the sum of the forces in the y direction equals mass times acceleration again, but notice there's no movement in the y direction, so that is 0, implies that F normal minus the weight equals 0, or that F normal equals the weight, and if you recall, the weight is mg. Let's call the first equation number 1, call the second equation number 2. From equation 1, we can find that A is minus Fk over m, and if you remember that Fk is also mu k force normal, then we get mu k F normal over m, and if we plug in that F normal is mass times acceleration due to gravity over m, we get that the acceleration is mu k g. If we now assume that the acceleration is constant, then we can say that, let's write down assuming A is constant, which it is, right? Because the coefficient of friction is not changing, G is not changing. Then we can say that V final squared equals V initial squared plus 2 times A times x final minus x initial, or we can rewrite this as V initial squared plus 2A delta x. And that means if since this is braking, we know that we can assume V final is 0. So this gives us that 0 equals V initial squared plus 2. Instead of A, we have minus mu kg delta x. So solving for V initial, we get the square root of 2 mu kg delta x, where the negative, if you move it over to the other side, it becomes a positive. And now if we plug these numbers in, we get 2 mu k is given as 0.60, g is 9.8 meters per second squared, and the length of the car, or the skid marks, was 290 meters. If we plug this in, we get about 58 meters per second, which is approximately 210 kilometers per hour. So very, very fast.